So this is the second lesson on exponents. We're going to look at negative exponents and scientific notation. So just to provide a little motivation for negative exponents, if we had simplify x to the fourth over x to the sixth, and sort of to drag out the top and drag out the bottom, what's going to happen? So the x to the fourth is x times x times x times x, and x to the sixth we have 6 x's. We can cancel, right? 1, 2, 3, 4 of those, and what are we left with? Just a 1 on top. And so we're left with 1 over my 2 x's, which gives me 1 over x squared. But using our property we learned from an earlier lesson, if we have a to the m over a to the m, this is a to the m minus n. I can just subtract the exponents. So what happens? X to the fourth over x to the sixth equals x to the 4 minus 6, which is x to the negative 2. So both of these are equivalent to each other. Just gives you a little motivation that 1 over x squared is x to the negative 2. So in essence, all we do is we will reciprocate the base if we have a negative exponent. So x to the negative 2 is 1 over x squared. Real quick, what would x to the negative 4 be? Good, 1 over x to the 4th. So it just reciprocates the base. And we'll see several examples here to come. So again, anything to the negative n is 1 over anything to the n. So if I had x to the negative 3, it'd be 1 over x cubed. Now with fractions, sometimes actually students find it easier with fractions. I have something to flip, right? I have something to reciprocate. So x over y to the negative n, when you're working with one like this, it's much easier if you'll get rid of the negative exponent first. So just flip the base, and that changes the sign of the exponent, y over x to the n. Now we can apply that n if we need to. So for example, if we had 3 over y to the negative 4, I would first flip it, change the sign to the exponent, and then apply that 4 to the top and the bottom to get y to the 4th over 81. Okay, now it's your turn. Go ahead and write these as a positive exponent. Okay, welcome back. I know you paused it. So, this first one, 5 to the negative 3, is going to be what? 1 over 5 cubed. And we'll leave it like that, just as write as a positive exponent. What about z to the negative 4? 1 over z to the 4th. And how about 2/5 to the negative 3? We're first going to flip it. 5 halves cubed. And technically we've done what it said to do. Write as a positive exponent. We've done that. Let's go ahead and finish this out though. So we'll have 5 cubed over 2 cubed. 5 cubed is 125. Divided by 2 cubed, which is 8. And we'll often skip this step here, 5 cubed over 2 cubed. We'll do this in our head. 5 cubed to get 125 and 2 cubed to give me the 8. Let's keep going. Write with positive exponents. So 1 over x to the negative 3 is just x cubed. Again, when my negative exponent, I reciprocate the base. X to the negative 1 be 1 over x to the 1, but we'll generally don't put the 1 there, right? It's understood. You need to pencil it in, you can. How about these next two? Try these next two. Pause the video here so you can get these. Okay, these are highly missed. So if you tried these, if you missed them, you're in good company. So the question is, what's being raised to the negative exponent? Just the x. So the x is the only thing that gets moved. So the 3 stays where it is over x squared. So go ahead and try this last one. I think you can get it. Okay. So the question in your head needs to be, what's being raised to the negative exponent? The y is, so the 4 and the x squared stay at the top, and the y cubed moves to the bottom. So again, if it's a negative exponent, it shifts its place from numerator to denominator or denominator to numerator, wherever it happens to be. If it's not, it just stays put. Okay, try these. Okay, welcome back. So, what's being raised to the negative exponent here? Just the x and negative 2. So that's the only thing that moves. So 3x squared. Often students will flip the 3 as well. But again, the 3 does not have a negative exponent tied to it. What about the next one? 15 stays put. but the y cubed moves up and the x to the fourth moves down. So the negative exponent shifts its position from top to bottom or bottom to top. Okay, 3x squared to the negative 3. So I'm going to first flip. I'm going to reciprocate the base, so it's going to be x squared over 3, and that changes the sign of my exponent. Now I can apply the 3. So x squared cubed is x to the 6th divided by 3 cubed, which is 27. Remember, 3 cubed is 3 times 3 times 3. We don't just say 3 times 3. Okay. Now let's express these using negative exponents. And you may be thinking, why would I want to do that? In subsequent courses, a lot of our formulae are sort of rely on the variable term being in the top. So let's go ahead and get a little practice doing that. So again, if I want to write that using negative exponents, we're going to say 4x to the negative 2. How about this next one? 5 to the negative 6th. Next one, the 1 over x squared is x to the negative 2. And 1 over 5x cubed. A couple different ways we could do this one. My intent here was to have the constant term stay there, and then the x to the negative 3 move up top. You could have, and I certainly wouldn't have marked it wrong because instructions aren't maybe as clear as they could be. They're a little ambiguous. Multiple answers here. We could say 5x cubed to the negative 1. I intended for you to do this right here, though. Okay, simplify. Express the final answer without negative exponents. So now we can actually do some combining here. So 4 to the negative 5 times 4 cubed. If you remember your property, what do I do when I have multiplying like bases to the exponents? Good, I add them. So negative 5 plus 3 is negative 2. But we want to express the final answer without negative exponents. So this is going to be 1 over 4 squared, which is 1/16. How about the next one? Again, I can't combine anything in parentheses, but what I can do is apply this negative 3. So this is going to be x to the negative 2 times negative 3 is 6. Y to the negative 9. And again, let's rewrite this without negative exponents. So x to the 6th divided by y to the 9th. See if you can do this last one on your own. Go ahead and pause it. I'll be waiting here for you. Alright. So we're first going to flip the base. 4 divided by x cubed squared. Now we can apply the 2. And we'll get 16 in the top. X cubed squared is x to the 6th. Example 7. See if you can do these two. We're stepping it up a little bit. Okay, a couple of different ways we can go here. We can apply this negative 2 onto these, or we can just go ahead and reciprocate it. Let's reciprocate it. So 1 over 4x squared y to negative 3 squared. Again, when we reciprocate the base, we change the sign of the number. You didn't have to do it this way. We could have applied the negative 2 to each of them, and maybe I can do that one as well. 1 over 4 squared is 16, and x squared squared is x to the 4th. That's going to be y to the negative 6th. And let's rewrite this one more time. This y to the negative 6 I can push up top. So y to the 6th over 16 x to the 4th. Now maybe it would have been easier to go ahead and apply that negative 2. Let's try that. So method 2 be 4 to the negative 2 x negative 4 y to the 6th. Let's rewrite without negative exponents. So that's going to be y to the 6th divided by 4 squared divided by x to the 4th. And one more time, y to the 6th divided by 16x to the 4th. So about the same number of steps. I don't care which way you do it. Okay, this next one, example 7. We will go ahead and, you can go ahead and change to negative positive if you want to, but let's go ahead and just combine our terms here. So 3 times 4 is 12. X to the negative 3 times x squared is x to the negative 1. Y negative 2 times y is y to the negative 1, right? Because that's an understood 1 there. Now to rewrite this without negative exponents, 12 does not have a negative exponent on it, but the x and the y do. So over x, y. You could put 1s there if you wanted to, but they look better without. Now let's try a couple on your own. Let's convert 4.21 times 10 to the 5th to decimal notation, and then we'll convert 3.234 times 10 to the negative 2 to decimal notation. Okay, so what are we going to do? We got 4, 2, 1. Decimal point was right there, so I'm going to move it 5 places. 1, 2, 3, 4, 5. And I'll fill in my zeros. Now when you're writing these on a test, I want you to rewrite that number so it doesn't have the little bloopy line underneath. So 4, 21, 1, 2, 3. And you can put a little comma there. How about the next one? 3.234. So 3, 2, 3, 4. It's the negative 2, so I'm going to move 1, 2. And there's my decimal point. So it's going to be 0.03234. Again, this 0 here is optional, but it often looks better before decimal. Okay, convert to scientific notation now. So we have 230,400,000. Do these two on your own. All right, welcome back. So we have 2, 3, 0, 4. We go until we get to the last non-zero digit. See how the other ones are 0, so we don't have to write those. So there's our decimal right there. The decimal always goes to the right of this first number here. And how many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8. Hope I did that right. So we say times 10 to the 8th. Okay, how about this one? Now I put some spaces in here just to make it easier on the eyes. They don't often have that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, 2.3 times 10 to the negative 11. Because again, I've got 2.3, and to get it to be this small number, I got to divide by 10 11 times, and that's what that means. So again, it makes it easier to read really large numbers, really small numbers. It's really easy to compare orders of magnitude. It's easy to just look at the times 10 to the power. 10 to the 8th versus 10 to the 5th. I can compare 10 to the 81st and 10 to the 52nd. I can compare orders of magnitude much easier this way, rather than sitting there trying to count zeros. And also it avoids regional differences. I mean, the word billion, for instance, means something different in the U.S. than it does in England. So using powers like 10 to the 9th and the 12th avoids any sort of misunderstanding. So let's see how we can use the calculator to do this. So 3.8 times 10 to the 4th times 2.1 times 10 to the 5th. So we're going to use this EE key. And so when you press the E, only one E is going to appear. I'm not sure why that occurs, but that's how they have it set up. So we're going to do 3.8, and then you press the EE key, and then a 4. Again, that EE key means, this means times 10 to the, and then we put the number after that. And then press enter. And then you'll get the answer. But often we want this final answer in scientific notation. And so go ahead and press the mode button, as I've indicated here, and select scientific notation. And then press enter again, and you should get it. 7.98 times 10 to the 9th. Now often there's something called significant digits. This is really important in your physics and chemistry, your science classes. And what that means is we can only really be as accurate as our most accurate or least accurate number. So here we're only going to 1 decimal place on each of these. So technically I can only go to 1 decimal place on this one. So this answer here would be 8.0 times 10 to the 9th. Now your calculator can automatically do that. If you'll change this float, you can look at here and say, okay, I've got to float it out only to 1 decimal. I select that 1 there. And I'll show you a live example here pretty soon. So see if you can do this one on your own. Okay, let's see how we can do this. So we're going to put parentheses 3.16 and then times 10. So you're going to press second, comma, 4, and then close parentheses. And the next one, times 5.17, second comma, times 10 to the 3rd. Make sure that's clear. See how that lines up. And then press enter. And we get this big number, but I want to rewrite this in scientific notation. So we can either do it in our head, but often it is kind of hard to count on this, that you hate to miss it for that. So let's press mode, scroll over to psi, and at the same time, let's go ahead and say let's float it out to 2 places. So come down to float. Okay. And then just press enter again, and it's 1.63 times 10 to the 8. 1.63 times 10 to the 8th. Do not write 1.63 E8. I'll count it wrong. Okay, this is really more of a calculator lingo, so don't write that. Rewrite it as this in scientific notation. Example 12. Try this one on your own. Okay, it's done exactly the same way. I'm just going to type it in. You definitely don't need the parentheses, but they're just sort of nice visual sometimes. Negative 2.08 times 10 to the second E if divided by 3.14 times 10 to the negative 2. And again, I think we've already floated it out, second notation, and we floated out the 2, so we're good. So just press enter, and we get 6.62 times 10 to the 6th.